Hello, and welcome to part B of the 1947 Chevrolet car radio. I guess we'd call it Resurrection. How's that? I am going to, in this episode, we're going to try to get, we're going to replace this capacitor because we found out the one I have actually measures 6 nanofarad, which is the correct value, and that's a 6,000 volt cap. This one was only 1600, so even though this is new old stock, it'll be fine. 6,000 volt cap. Going to ground pin 2 and connect pin 7 to this point here where there's some filtering, and we'll put the cover back over here. I'm going to replace this coupling capacitor here, which goes to the grid of the that tube's not even all the way in the socket. Gonna replace this capacitor, which is the coupling cap to the 6V6 grid, and then we'll put some voltage on these filter caps. According to this, it's 20 and 20 microfarad, and there's probably another 20. There's 3 20s in there. One's the cathode bypass for the 6V6, and the other 2 are filter caps. So we'll find out. We'll do the standard inject the voltage and see if we have any serious leakage, and or if the caps are viable at all, just for power up purposes. And then we'll try putting some power on here and see if it wakes up. I'm expecting to have some noise issues because the front cover is off and the rear cover is off. These radios are designed to be all closed up and with all the compartments sealed so that they don't pick up a lot of hash and a lot of background noise. But we'll see how well it deals with being opened up like this. I am going to suggest to him, if he doesn't have a back cover, excuse me, when he puts when he puts this in the vehicle, that he gets some brass screen or something to cover the back of this so he doesn't have a lot of ignition noise pickup. These radios are supposed to be sealed up tight in an automobile environment, and the reason they're all copper coated and enclosed in metal, even a modern car radio, is all sealed up tight so that ignition noise and all the electrical noise in the car doesn't get into it. So I'm going to turn off the camera. I'm going to change that cap. I'm going to change this cap. I'm going to wire up the heater on the 6X5, and then I'll come back. We'll test the filter caps and put some power on this and see where we stand. Okay, the buffer capacitor has been changed. The heater has been wired. This brown wire right here is picking up our 6 volts. I've connected our DC power supply. Our coupling cap up here has been changed, going to the output between the first audio and the output tube to the grid of the output tube. And we're ready to see if the capacitors are any good. See if it's safe to power it up. Now, every capacitor in here, every paper cap's either 400 or 600 volts. The electrolytics are 450 volt caps. So I feel perfectly safe about winding this up to at least 100 volts. Let's see, that's in the discharge position. DC on. There's 100 volts or so. Let's see what happens. Uh-oh. It's drawing current and it's not going down, or is it? Nope. It's a steady 25 milliamperes, so something is gonzo. What would we draw if it was a dead short? So 50 milliamperes would be a dead short. But something's drawing 25 milliamperes, so we can't power this thing up until we track that down. Whether it's an electrolytic or something else is miswired, we're going to have to go digging. Unfortunately, the electrolytic is hidden behind the whole tuning section here. Actually, it's behind this pot. So to get to that, I'm going to have to, I'll shut this off before I forget about it. I'm going to have to pull the tuning cap out, and we'll just start disconnecting at the electrolytic and see what we end up with. But something's out to lunch. Shut off that power supply for now. Let me get the tuning unit pulled out and we'll take a look. Alrighty, the filter can has 3 20s in it. You got a 20, a 20, and a 20 up here for the cathode bypass. These two are 450 volts. This one's rated 25 volts. So there's a 20 microfarad at 50 volts. I'm going to replace that. I'm just going to put it right across the cathode resistor right in here. And we'll just cut this wire right out of here and get it out. So we only have to deal with 2 sections down here in the high voltage area. So I'm going to cut out, and this isn't our problem because this isn't even in circuit at the moment, but I'm just going to get that out of the way. It's probably one of these capacitors has gone shorted because there's not much else here that's been replaced, unless one of these to the chassis capacitors has gone bad or been disturbed, but I don't think so. Those are pretty reliable. They're just like a big washer with a piece of mica between them, and they're just riveted right to the case of the radio, and they're all over the place on here. There's one here. Oh, let's see. I know there's several more. There's that one. Oh, come on. I know. Oh, there's another one. They're in several places throughout the radio. This was a common way for them to put bypass capacitors into ground. They end up being very low inductance this way, and they do a good job of bypassing RF to ground because they're built right into the frame of the radio. They just rivet them right to the frame of the radio. You probably, well, there's one right here. That little device that looks like a washer with a rivet through it and a piece of mica. They're riveted right to the frame of the radio. So let me get those changed out and we'll find out which one of these caps has gone bad. Okay, I just clipped the 2 wires that go down to those capacitors, and I'm pretty confident that that current draw is going to be gone. So we'll hook this thing up right back where it was. This side that I'm clipped to here, where did I put the schematic? Oh, it's there. Right now I'm tied into what would have been this point right here, and the other side of these resistors is this point right here. They have 2 of them in parallel just to carry the load. And with these clipped out of the circuit, of course I've changed the one. That's not the frame, is it? I've changed this one out. We know that's not the problem because that's a cathode bypass and that tube wasn't even active. So that wasn't the issue. It was going to be one of these 2 capacitors here that was bad. Probably the second one. I'm going to guess it was this one, because if it had been this one, I think I would have been drawing a lot more current. I was probably drawing the current through these resistors to ground. That's a guess. Actually, we could verify that. I could move that down here. That would be the second capacitor, would be this one, because this is the one that only had 1 wire going to it. And let's see what happens when I turn the unit on. Here comes our voltage coming up. And sure enough, that's the cap. It was that second cap that's giving us the problem. And let's see what the first section looks like. It may or may not have been passable, but it's going to get replaced at this point anyway. Even that one's drawing a little bit of current. Yeah, they were both extremely leaky. Okay, so we know for sure that that was the issue. The beauty of it is these new capacitors, one will tuck right down in here and one will tuck right down in here. I've got a grounding point there. One positive goes here, one positive goes there. It's going to get them right out of the way, and we can leave the original can down behind here, so when they look in this side of the radio, it looks original. With the back off, you'll see the old can from the old electrolytic still sitting there. I'm going to rip the terminals off of that just so that it can never get hooked up again, and I'll have to run a fresh wire from inside the high voltage shield up to this point, because this wire went down to the capacitor and there's a second wire that came down to the capacitor where they joined. So I'll replace this with a single longer wire that goes to the rectifier. This wire can go away entirely, as did the other one that was for the cathode bypass. I don't even know what I did with a piece of wire. I probably threw it away at this point. But the cathode bypass ran all the way down here to that can capacitor as well, because back in the day they didn't have electrolytics like this or like this. They were all massive, so they had to run wiring down to the electrolytic instead of putting the electrolytic right at the point of operation. Alrighty, let me get that cleaned up, that wiring cleaned up, and we'll proceed to the next step. Okay, we have a new red wire here running from the cathode, whoops, banging into the camera again, running from the cathode up to the first capacitor, which branches off and goes to the primary of the power transformer. There's our red wire, there's our first capacitor, there's our wire heading off to the primary of the, did I say power? I meant audio transformer. Then we've got that pair of resistors right here, and that goes up to pin 4, which is the screen. 1, 2, 3, 4, and there's our second capacitor right here. And there's a ground tab cut into the chassis right there. It's like somebody at the factory knew that in 2021 we'd be putting new capacitors in and we were going to need a ground tab right there. They planned it for us. How nice of them. And of course we have our cathode bypass here. Now I'm going to back the camera up a little bit. Swing the viewfinder out so I can see what's happening. And our power supply is still on over there, so I'm going to connect to the same point we connected to earlier. And down here. And we'll swing our camera around. And I'm going to turn on the DC supply, 100 volts, and we'll hit the test. Perfect. And you can see the current dropping off. Now those caps are brand new. It's probably the first time they've seen voltage since they left the factory. And they blink when we go the other direction. So now we have good filter capacitors in the circuit. Tested. We have apparently no other serious leakage. Now we know all of these paper caps are bad, but we'll get in there and change those just as soon as we make sure that that we have a viable set here. So I'm going to turn this off, turn that off. We can put this guy away. We're pretty much through with it. Push him back out of the way. Let's see. Over here, well, let me bring it over this direction. Let me shut you off. Here we have an actual automobile antenna with the correct connector on the end and everything. And I forget whether this came from the 60 Chevy or if this came from the DeSoto. I don't remember which. Now I'm expecting this radio to have a lot of buzzing and noise in the background, so don't get too upset about that. Nothing shielded, and it's noisy as sin down here in the lab. Fluorescent lights, LED lights, digital equipment everywhere. Well, why isn't it? Oh, there it goes. The antenna is now plugged in. Maybe I should move you guys. Well, let's see here. What's one of the first things I want to do? The first thing I think I want to do is still verify that the DC power lead is not short-circuited. It should be fairly low resistance because of the tubes. Are we in frame here? I hope so. I'll take my trusty fluke, trusty now that it's been repaired once again. Or again, it's the first time it's ever failed me. But it should be many more years before it does again, because I chopped like 6 inches off the wire and put fresh meat up inside here. So get on the ground, get on the power lead. Okay, that's not a good sign. What is shorted where? Power switch is off. I think I know what happened. When I was in here, I noticed that the insulator wasn't lined up correctly, even though it looked okay from the... Yep, sure enough. That's not good. I shifted the insulator slightly to get it in a better position, and I think I toasted myself. So let's find out what's wrong with that. It's rather tight quarters down in here. I don't think I can get you in frame and see what I'm doing at the same time. See, our insulator is... Maybe I ought to just replace that. In fact, let me see how thick this is. $11 thousandths. Perfect. Absolutely perfect. I have just the thing to replace this with, and it'll be a better insulator to boot. This is very expensive, 12 mil Teflon tape. And I think it's 1,000 volts per mil this stuff is good for. So we're looking at 12,000 volts worth of insulation here. I think it's 1,000 volts per mil. It's a bunch. So I'll just chop a piece of this off, and we'll stick it right to the back of that capacitor. And we'll have a new and improved insulator on the back of the cap, or forming the cap. This actually forms the capacitor. This is the dielectric. The chassis is one part of the capacitor, and this forms the other half of it right here. Let me clean that up with a little alcohol or something first, and then we'll stick it on there. I imagine what happened after I moved it is when I tightened up this bottom screw, there's a little nick in the paper here. Probably pulled it down just far enough to touch the chassis, so I'm glad I checked. Let me go get some alcohol and clean that up. Are we in frame here? Yeah, move over a little bit. We have our Teflon tape in place. We'll slide this back down here. I've got a couple of little holes punched in it so I can start my screws through as soon as I can find the location of them. Oh, they're way over there. Okay. Try this again. Yep, there's one right there. And we'll get this screw started. There's one. Okay, yep, there it goes. There's two. Okie dokie, let's try that again, shall we? That should have fixed it. Tip it. There we go. Gotta get on a good ground here, make sure I've got a... Alright. Okay, fixed. That insulator is certainly better than the one that was in there by a long margin. Let's see, I'm going to put this on DC volts, or as the Russian guy I worked with used to say, volts. How many volts, Vernon? Dmitri, he was a great guy. Worked with him for a number of years. He came over as soon as the Berlin Wall fell. Oh, you're not seeing anything, are you? I'm sitting here yakking away and haven't even moved the camera. What a doomus! I'm gonna go put the acetone away. I remembered to push the button this time. We're going to power this baby up with my HP 6264B, and as Ave would say, this is a skookum piece of equipment. It says up here 0 to 20 volts, 0 to 20 amps, but in actuality it does 0 to 24 volts. 0 to 20 you get like 0.01% regulation on the DC voltage, and the HP manual tells you how to go inside and move the voltage limit up, but the regulation falls to 0.03 or 0.05 or something ludicrous like that. They only spec it to 0.01% to 20 volts. If you take it to 24 volts, the regulation drops down to, you know, a value that's still far better than most mortal humans will ever need. And the guys who do military radios and so on and so forth, perfect for powering your 24 volt military gear. You know, you can do your 6, 12, or 24 volts. The beauty of this thing is you can get the full 20 amps from 1 volt to 24 volts. Because when you set the regulation, it also sets the voltage on the primary of the transformer. It's got, I think, what the heck are they? I think they're triacs. Anyway, they control the primary of the transformer. So you only have a small voltage drop over the pass transistors. The pass transistors only have to regulate within a small range of voltage drop so they don't overheat. So what I'm going to do is, right now I have, is that in frame? Yeah, I have the output short-circuited. And I'm going to set this for about 5 amperes. So let's turn the voltage up, or let's turn the current up. There we go. Because we have a dead short right now. So there's 5 amps. And then I'll take my short off. And then I'll set my 6 volts. 4, 5, 6. There's my 6 volts. And if I put my short back on there, come on. Gotta get, oh, there's my 5 amperes. It'll sit there all day long with a dead short on it, and it doesn't care. Beautiful little supply. And I've got some heavy duty, I think these are number 16 jumper cables, or jump, right now the radio's off. And we're going to see what happens. We can't bring this up slow because the vibrator won't start if we do. So we've just got to go for broke. And we'll look down here at our B plus and let's see what happens. And I don't hear the vibrator. It's drawing. It's drawing. It started out at 5 amps. It's dropping to 3, so the tubes are warming up. Yeah, all the lights are lit. Let's give the vibrator a smack. Let's see what happens. Nope, the vibrator's not working. We're down to 3 amps. Alright, let me pull that vibrator out of there and see if mine works. I'm hoping that that 0.5 microfarad capacitor inside of that transformer isn't shorted. Let me dig out my vibrator and okay, we're metered up again. Let's see what happens with this other vibrator in there. Oh, it's going. It's running. And our B plus is coming up. Coming up pretty quick. There's 100 volts. 150. 160. I probably should drag a speaker over here, huh? Why don't I do that? Alrighty, we still rolling? Did I? Yep, it's still rolling. What do you know? And here. And there we have it. We still got 6 volts, 4, 5. We're a little low on voltage. Let's bring the current up. There. It's taking almost 5 amperes to run.
Now G7 are warning Russia there are consequences if innovation takes place. I think you've heard the administration, you've heard Biden say how tough he was in that call and mince no words.
Looks like they've got a 12 volt lamp in the dial light.
He did not back down. He played. He said he was the aggrieved person and stopped with all this democracy. So he was very.
And actually, it doesn't sound that noisy considering everything's open and unshielded. And I don't even have the antenna extended. It's surprisingly quiet.
When I say this real sadness, we will meet like this. After 18 years, I have decided to leave Fox. Try something new.
Tone control is working.
For all the things I'm interested in, I'm ready for a new adventure, and I hope you'll check it out.
An ancient pitch, but one I want.
Oh, that's probably my LED lights causing that buzzing. took care of that. That sounds like vibrator.
What we have done here at the department is continue to have conversations with our allies and partners about this situation.
At 6 volts, it's 5 amperes, which is right around what I expect. And we've got, the voltage is lower than I thought it would be. It's 175.
Is simply not going to change.
Putin's already figured out Joe is not going to lift
And you
a
can see
finger.
it's dancing around a little bit. But
We haven't figured out what Putin's intentions are. I know what he's
the
doing.
radio's playing fine. I don't have the specs for what the voltages should be in this set,
That's probably what he's doing.
because the schematic doesn't have anything marked.
There on the border.
And I checked today on my rider's manual I ordered. I paid for first class postage, and the guy sent it, what do you call it, oh, the rate for books and papers and all that stuff. The damn thing's still in California. That's going to get written up in his review.
Hunter made a fortune from both those countries. And next week when he talks to President Xi of China, that's another...
Alright, there was one other thing I wanted to do. I got to talking and now I've spaced it. Oh, now that it's running, I think I'll try his vibrator back in there again and give it a couple more smacks. I'm going to suggest, Tom, that you either buy one of the solid state ones. This one was sluggish to start, and it's going to give you troubles. It's an old pull, and I just as soon start at that time. Yeah, but it doesn't sound good. It sounds ill. Oh, that's what I was going to do. Get the camera down here so you could hear it. You can hear it buzzing away. I'll shut it off. Turn it back on. And it's real hashy now. Oh, cleaned up. Yeah, that vibrator's on its last legs.
He's putting in place the capacity to do so on short order, should he so decide.
But it was good enough to show us the set works.
We will respond resolutely.
But you hear the hash on that startup? That vibrator's going.
That we've refrained from using in the past.
High impact economic sanctions.
I can
Really going to scare
finish recapping this, and we'll do a quick alignment on it if it needs it. And I'll leave it up to you. I can ship it back with your vibrator in it, and you can order one of the solid states or see if you can find one somewhere. I know they're a big chunk of change, but the solid state ones are going to produce a lot less hash,
I'll ask you both the same question.
and they're trouble free over the life of the
To have
radio.
a block party, it's to invade Ukraine. That's what seems to be in the very near future. Your take
But I
or
can
back?
hear this. Yeah, this vibrator's not in the best of shape, but it is running. There's always a little hash from them, but when they get wavery like that.
What led to stalling the drive is my point.
Oh, I know what else I was going to do. I'm going to change the lamp, the pilot lamp, and give you the right voltage. The longer the set runs, the more the voltage is coming up. So the contacts in that vibrator are probably cleaning up as it runs, but I can't in good conscience send it out of here with that one. It's okay for testing, but it won't probably live very long. So I'll leave that up to you, what you want to do. It's just a plug-in unit.
Of Life Sciences Ontario. I'm also speaking to you as a Canadian scientist who sees trouble on the medical.
Got plenty of volume. Okay, I'm going to finish recapping this now that we know it works, and we'll move on from there. Alright, it's coming up on midnight again. I'm going to call it an evening, and we'll finish this up in another episode. There isn't much more to do, but we'll get it recapped. We'll take a look at the schematic and give our best shot at guessing what the alignment is on this, because I don't have the information. I do have 2 or 3 other schematics, and I've got a good idea of what needs to be done, but we'll take it slow and see what the results are. And that's it for tonight. We'll see you in the next episode. Take care.